Hello viewers, in today's session we are going to discuss an important problem from matrices, and this problem belongs to this important concept that is known as the reversal law for transposes of matrices, right? So in this problem we are given two matrices. The first one is the matrix A, which is a column matrix -2, 3, -1, and the second matrix, that is B, is a row matrix that is 2, 3, and -5. And here we have to verify this law that is known as reversal law for transposes of matrices. So here the transpose of the product of matrix A and B is equal to the product of the transpose of matrix B and the transpose of matrix A. So this is a very important rule while we find out the transpose of matrices, and here this dash represents the symbol for transpose of a matrix. So we can also write this relation as the product AB transpose. Here we write T, and then we can write B T and AT, right? So here when we take the transpose of the product of these two matrices, then the individual transposes get reversed. That is, first we have the transpose of matrix B, and then we have the transpose of matrix A. So we'll verify this law for these two matrices, where A is the column matrix and the order of this matrix is 3 times 1, that is 3 cross 1, that is 3 rows and 1 column. And here the order of this matrix is 1 cross 3, that is 1 row and 3 columns. So to verify this law, let us first take this left hand side. So our left hand side is transpose of the product of A and B, right? Now let us first find the product A and B. So here the matrix A is -2, 3, -1, and this is 3 cross 1, and here the matrix B is 2, 3, and -5, and here the order is 1 cross 3. Now see, whenever we multiply two matrices, then the condition for the product to be defined is that the columns of the first matrix should be equal to the rows of the second matrix. So here this matrix has column 1 and this matrix has rows 1. So 1 and 1, they are equal, right? So the number of columns are equal to the number of rows. So the order of the product of these two matrices is 3 cross 3, right? So here when we multiply these two matrices, we'll get a matrix of order 3 cross 3, that is 3 columns and 3 rows. So here we have the elements that are denoted by these dots, and we'll find the dots by multiplying these two matrices. So now when we multiply these two matrices, first we multiply these three elements by this element, that is -2. So first we'll multiply -2 and 2. So here we get -4. Then we multiply -2 with 3. We'll get the second element of this row, that is -2 times 3, that is -6. And then we multiply this -2 with this -5. So we'll get minus minus plus, so we have here 10, right? Then the second row can be obtained by multiplying this 2 by 3, will get 6. Then this 3 by this 3 will get 9. And then this 3 by this -5 will get -15. And the third row can be obtained by multiplying minus 3 with this 2. So we'll get minus 1 times 2 is minus 2. Then minus 1 times 3 is minus 3. And then minus 1 times minus 5 is plus 5. Right? So this is how we can obtain the product of A and B, that is a 3 cross 3 matrix. So now we have to find out the transpose of this product, that is transpose AB. So AB transpose is it can be written as minus 4, 6, minus 2, minus 6, 9, minus 3. Then we have 10, minus 15, and 5. And here we write the dash, that is the transpose. Now see, the transpose of a matrix, it implies that we interchange the rows by columns and columns by rows. So here this first row, that is minus 6, minus 4, minus 6, minus 10, it becomes the first column. So we have minus 4, minus 6, 10. Then the second row becomes the second column. So we have 6, 9, minus 15. And the third row becomes the third column. So here we have minus 2, minus 3, and 5. So the transpose of the product AB is given by this 3 cross 3 matrix. So our left hand side is given by this matrix. So now let us consider the right hand side. So in the right hand side we have B transpose multiplied with A transpose. Right now the B transpose is given by 2, 3, minus 5, and here we write the dash. And then the A transpose is given by minus 2, 3, minus 1, and here we write the dash. Now see, the transpose of this matrix, that is the rows becomes columns, right? So we can now write 2, 3, minus 5. And here we have the column matrix. So this column becomes the row. So here we have 2, 3, and minus 1, right? Now this is 3 cross 1 matrix, 3 rows and 1 column, and this is the 1 cross 3 matrix, that is 1 row and 3 columns. So we can see that the number of columns are equal to number of rows. So here the product of these two matrices is given by a 3 cross 3 matrix, right? So here we have the elements which are represented by these dots, right? So here we have 3 cross 3 matrix. So now to multiply these two matrices, will again follow the same steps. So here this 2 is multiplied with this minus 2. So we'll get here minus 4. Then 2 is multiplied with 3. We'll get 6. And then we multiply this 2 with this minus 1. So we have 2 times minus 1 is minus 2. Then we'll get the second row. So we'll multiply this 3 with minus 2. So we'll get minus 6. And then we multiply this 3 with this 3. So we'll get 9. And then this 3 with this minus 1. So we have minus 3. And to get the third row, we'll multiply minus 5 with this 2. So we'll get minus minus plus. So 5 times 2 is 10. And then minus 5 with this 3. So we have minus 15. Minus 5 times 3 is minus 15. And then minus 5 with the minus 1. So we have plus 5. So here we have plus 5. Right? So we can see that B dash and A dash, this product is equal to this matrix. And now we can easily conclude that this matrix is minus 4, 6, minus 2. Here we have minus 4, 6, minus 2. Here the second row is minus 6, 9, minus 3. Here we have minus 6, 9, minus 3. And here we have 10, minus 15, and 5. And here also we have 10, minus 15, and 5. So these two matrices are equal to each other. Hence we can say that this quantity, that is transpose of AB, is equal to B transpose multiplied with A transpose, right? So this is how we have verified this reversal law for these two matrices.